All right, so IP, maybe before we go into the meat of the discussion, I would like to ask the question, what is it really, IP? And things have been evolving over the years, and I think from time to time it's good to ask ourselves the question, is it patents? We hear a lot about patent activity in the market, clearly. Is it copyrights? I learned at some point that software is difficult to patent and therefore it gets copyrighted. Is it about know-how? A very vague concept. Is it design blocks? This we understand a bit better. Is it RTL? This we understand very well, actually. Is it firmware? Is it content? Is it manufacturing recipes or technology? I guess the answer is that it's all of the above. This is what really we think at ST of IP in general terms. And we actually buy all of these things, okay, on a regular basis as part of our strategy. Now, the way to maybe to let's say think of IP in general terms is, in order to deliver an experience to a user or a consumer, you need a number of things to have. You have to have a service. You have to have content. Obviously, you have to have a system to deliver that content. You have to have these components, these subsystems, and so forth, all the way down to some technology that basically enables all of that. So that clearly is a chain of things, components, let's say, that are relevant to the definition of IP. Then, in addition, you have these, let's say, from idea to implementation, all the chain of the activities that need to happen to actually make it real. And then, a number of things. Then the customer, typically a customer or somebody or a startup comes up with an idea of an experience, a new killer app for the consumer. Then this gets translated somehow into a requirement specification for the various components there. And then through some heavy concurrent engineering, heavy R&D, and a lot of sweat, I guess, in the end, you end up with some kind of experience that the user enjoys, and hopefully we have some relationship with the idea, but not necessarily the idea in the first place. So that is quite clear. The question for us is therefore patents. Inventions do get patented, at least at system, subsystem, and technology and hardware level, clearly. And patent is increasingly important in our industry, I believe. Then, of course, technology. We need a PDK to start developing some SoCs. We need, of course, technology recipes and so forth. This is also something that is increasingly valuable. Then, in order to build a SoC, you have to have design IPs, hard IPs, and soft IPs. Then you need some software and firmware running on it, either copyright code, i.e. proprietary code developed internally in most cases, or FOSS-free open source software, which of course is increasingly important here. And then ultimately some content that will run on these systems. Now, apart from all of these well-identified pieces or IPs or components, the rest of it is the secret sauce, is basically know-how, trade secret, the thing that allows you to glue all of that together and makes it effective and efficient. Now, of course, in this conference here, we will be focusing a lot on hard IPs, soft IPs, which are, of course, critical to the design of SoCs. But we shouldn't forget about all the other things that make up a system, and in the end, allow us to deliver a user experience. Now, for SoCs, clearly what really is key is, of course, these various components here. I have deliberately highlighted software, which is an increasing, let's say, trend. I think it's a trend towards sourcing more software, whether in open source, in the open source community, or proprietary software developed by third parties. I think this is a trend that we will continue to see prevailing in the future. So what ST buys, you can see in an average year, 2011 in the middle and 12 in the outer ring here, we do about 60, 70 deals a year, more or less. And you can see the types of stuffs that we buy. There is a little bit of manufacturing, but we tend to believe that we're good at that, so we don't buy so much of it, actually. But we're buying a lot of hardware IPs. You can see it's about 20, 25% of what we buy. Soft hardware, so RTL is a big chunk of what we buy, of course, as you can imagine. Then firmware, some tools, product design. Actually, we sometimes buy completely developed product designs and then go to manufacturing with that and business. We buy increasingly, you can see the blue area here. We're buying increasingly, software and then patents. We're licensing patents, sometimes willingly, sometimes less willingly, but in the end, end up licensing those, and then we also buy some system-level IP, which are required for our implementations. So you can see it's very diverse, and it's not only about design IPs, as we could imagine. Now, you need to manage this, as everything in life, there's a chain of things, of course, and IP sourcing is also a chain of activities that need to happen. To start with, you have intelligence in the English exception of the word, obviously, meaning that basically you need to second-guess your customer. You need to second-guess your customer because he doesn't want to tell you what he has in mind, or he doesn't have a clue. So you have to actually guess what he will want at some point 2, 3 years out there. So it's a difficult task which is not done by one guy like a guru or of some kind. It's more it's a widespread, let's say, intelligence across the whole company, the whole organization. So you need to collect that collective intelligence and try to exploit it somehow. But then ultimately there's a business request coming from a division, product line, business unit, whatever. And then you need to scout for the missing piece of IP internally and externally. You are issuing RFQs to a number of vendors. And then you have to run this make versus buy analysis if the make is an option. Sometimes it's not an option, but in some cases, in many cases, it is an option, in the case of ST at least. So make versus buy. And then a sourcing decision. You need to contractualize those terms, obviously, and then, of course, get the IP delivered in time and when you need it. So to manage this chain, there are some criteria that you need to keep in mind, and I think those are the 3 criteria that we consistently apply across our various IP sourcing decisions. IP performance, obviously. You need to buy an IP that delivers the job. Okay, so you need to specify what you mean by that. But performance is obviously key. Performance means could mean gigahertz, could mean milliwatts, could mean milliwatt and gigahertz per milliwatt, etc. All of these performance metrics there. Risk of IP sourcing risk, and the cost of sourcing, obviously. TCO standing for total cost of ownership. An IP being a piece of silicon or a piece of code, depending on what it is, it carries a cost, a licensing cost, but also carries a physical cost, silicon cost in particular. So you need to capture all of that. So these are the 3 main criteria for sourcing IP that we use in ST. Then, of course, you get what you pay for. Unfortunately, in life, high performance typically is more costly, and therefore you need to know where you stand on this on these 2 axes. Okay. Then performance versus risk. Usually, the higher performance IP are the ones more difficult to actually do, and they end up being more risky to be developed, and therefore more risky to get licensed and to get let's say delivered. So again, this is a trade-off there. Then risk versus cost. There are maybe some low-cost solutions out there that end up being very risky to source for many reasons, and vice versa. More costly solution end up being maybe least risky. So you need to understand the trade-off there as well. So the problem that I face in my job basically is to manage the requests from these business owners, the business units. Usually they come to me with these ill-defined requests, like I need the best IP out there, okay? How defined is that, okay? I want the best IP at the lowest cost. This is something that I keep, of course, hearing a lot. I want a good IP at no risk for my project, okay? Assuming that there's a lot of risk in the project, he doesn't want to add on top of that, I suppose. I do not care about the cost as long as the IP performs to spec and is delivered on time. This also I keep getting from time to time. Now, what are the well-defined requests that we need to extract from these guys in the end? The well-defined request would be, I want an IP that delivers performance P, okay, delivered before time T, which is the time I need it, basically to integrate into my SoC at a reasonable cost and risk consistent with the overall project risk, i.e. the project bears some risks in itself, and you need to be more or less consistent with that, and this is what we need to define, of course, with this internal customer. I want the least costly IP at a risk which is somewhat similar to the other IPs, the one that I make, for instance, and the performance needs to be good enough for my market, basically. I think these are the well-defined requests that sometimes we struggle in let's say, discussing with these business owners, trying to extract what those requests are. So assuming we have these defined requests, then the requirement specification sets the performance threshold. Below, the IP is being disqualified in these RFQs, RFQ process. Over-performance looks to be good, but in the end, it's over-engineering, it's over-spec, and you end up, as I said earlier, you end up overpaying or taking... so what you need to have is, of course, an IP that is just above the specification with some cushion, but not something which is vastly over-spec'd. Okay. So if you do that, then it becomes essentially a cost versus risk situation once the performance is met and then defined. Okay. So assessing risk is not sounds good, but it's not that easy. You need to identify the various sources of risk. One of them is the fact that the IP may not be delivered, okay, to you or to the SOC team, at least not delivered in time when they need it. So you need to combine that with the risk that the IP may not be integrated in the SOC or maybe fail to be integrated in the SOC in a timely manner, and this can happen for various reasons. The IP may be integrated and be delivered and so forth, but may fail to meet market expectations. For instance, they may fail to deliver what the market expects in terms of performance, in terms of experience. And ultimately, there's also the risk of the IP being challenged out there, somebody claiming that they actually own it or own a portion of it through the form of patents. So these various risks combine. Unfortunately, they're not averaging out. They're just combining them. So you need to handle all these sources of risk. So we have this method of, let's say, trying to assess them vendor by vendor. It's a tedious process. I think what you need to keep in mind there is essentially there's no risk-free situation. You need to compare and benchmark risk versus your internal risks. Okay, so if you set your internal benchmark as, let's say, 100, how do I compare against an ST-developed, homemade IP? And this is where you find it easier to actually set these risks metrics. So this is something which needs to happen. It's also actually besides the numbers themselves, it's a very useful dialogue to have with the, let's say, the business owner, because sometimes through that process, you understand really what is the request and you can refine it. So I found it a useful process also for that reason. Then ultimately you get this 4-axis, and this radar screen, for instance, captures the let's say the outcome of that. So you can see source A, for instance, in this case, appears to be the least risky in all dimensions, while the purple source here, source E, appears to be less risky legally, probably because it's a stronger company and maybe with a lot of indemnification and protection like that. The IP appears to be least risky to integrate, probably because of track record and existing stuff that they already have, etc. But the IP is not mature. The market hasn't seen it yet, and maybe the IP is not mature, and therefore there's a risk of it not being delivered on time. So you have these types of chart that helps you also convey the conclusion of the analysis to your internal customer. Sometimes we also share that with our IP partners so that they can challenge the conclusion of that, and we have this dialogue. Okay. Now the cost, as I said, total cost of ownership, it takes, of course, the fees. It takes some royalties, if any. It takes the NRE, if any, none in this situation here. It takes IP silicon area projected through the lifetime of the IP and the product, and any ST integration costs that we incur, if any, again. So you need to calculate and add up all these various sources of costs, and of course actualize that to present so that you can compare things well. Now, then when you have done this cost, then this cost and this risk, then you can compare the various sources of IP, and you can say, okay, this is the best IP, the least costly, the least risky, and this is the worst. Where do I stand on these various sources? And here, the obvious choice would be A, but you see between E and B, it would, or if B were here and E were there, it would really end up being a trade-off, and you would have to have this discussion with your customer, a business unit owner, and say, well, I can offer two options, but one is much less risky but much more expensive. So the question then becomes, how much risk are you willing to afford? How much budget do you have, etc., etc. But I think using these types of tools is not so the science behind it, because there's a lot of judgment and evaluation, which is not very scientific. But it's a tool to discuss with the business unit and the project leaders to try to understand where they feel comfortable in this trade-off. Then what the common pitfalls are in IP sourcing. Cost, we usually miss or underestimate some cost components. For instance, specific NRE, specific integration tasks, people that will need to maybe package the IP in different ways in order to deliver the views that are missing from the IP vendor, for instance, etc. So those are costs that need to be included in the analysis. Sometimes you fail to account for the time value. It's, of course, the dollar in 5 years' time in the form of a royalty. Of course, carries much less value than the dollar today, which is a fixed and certain, let's say. Sometimes I hear people emphasizing and that when we deploy this P&L, of course, mentality in companies like ST, sometimes we end up, having this effect of emphasizing accounting rather as opposed to economics. Okay, so all the way up to senior level, they tend to try to minimize, let's say, accounting impact in the short or medium term, as opposed to the whole economics of the IP sourcing decision. So this is something that, of course, is very accounting. It's very US GAAP centric, and of course, if you change accounting system, the conclusion would be different. So it's really something that you need to try to resist and really think in terms of full economics. Risks are usually incomplete appreciation of risks. To give you an example, when you are sourcing from a startup, for instance, which is not in an IP business, a fabless company, you need to appreciate the risk of them disappearing within 2 years, for instance, in the life when you need them for support, for instance. So you need to appreciate all these risks. Believing that risks can be all contracted away so that you can buy an insurance or some clause in the contract. Impose some clauses that make you risk-free. This doesn't exist, of course. Even though you may have the perfect contract in the world, if the supplier doesn't honor the contract commitments, then you end up having to sue them, which, of course, is something that we don't want to do. We don't want to do not because we don't have the rights to do that, but we don't want to do because it doesn't help the project in the end. Okay, so you need to be careful at thinking that contracts are the ultimate solution for all of your issues. Underestimating risks under a make scenario also. Sometimes people are doing development and they underestimate the risks associated with that. So you need to look at statistics and try to be factual about that. Finally, performance. Leave performance undefined, performance spec undefined. This is a very common, let's say, pitfall. And over-specify. This is usually an engineering approach. You over-specify so that you believe you're safe. In the end, you end up paying more, and you probably end up taking more risks. So you need to. This is also a trap. Okay, IP sourcing trends on the demand and supply side. Demand side, we see more subsystems. I think it was mentioned earlier. More subsystems rather than individual design IPs, i.e., files plus controllers, for instance. This is clearly a let's say, in terms of my customers demanding IPs, this is what they would like to see. Okay, clearly a demand for that. More software, as I said. This is due to the fact that, as a company, IDM and supplying SoCs, we need to supply more software to our own customers. So, and because we're not, hiring thousands of people, etc., we need to buy more, essentially. More patent licensing. As I said, sometimes willingly, sometimes less willingly, but in the end, we need more. We need to essentially contract more licenses on patents. Sometimes as part of a technology transfer agreement, but sometimes just a patent license agreement. Winner takes all in some of the mainstream IPs. We see clearly. I have a word on this. On when you start unifying platforms, then there are fewer opportunities for suppliers to actually compete against each other, because essentially the platform freezes the choice of IP for a while. On the other hand, there are niches developing for system-level IPs, higher-end IPs, and this is something that typically is a very, let's say, rich market for startups in particular, developing specific system IPs that ultimately become a source of licensing. On the supply side, we see consolidation in the processor core market, CPU, DSP, GPU, with choices being fewer and fewer there. We see emerging suppliers in Eastern Europe and in Asia, on interface in particular. And we see diversification towards more system IP, which is also the same as before. Okay, in terms of Eastern Europe and Asia, this is the breakdown of what we buy in volume, with the origin of the various suppliers. You can see that, yes, UK is big, Western Europe is quite large, the US is big as well, but you see India, Asia, and rest of the world is still small, but you see these sources of between Eastern Europe, India, Asia. This was zero only a couple of years ago. So this is clearly now emerging, and I believe this will continue to grow volume-wise, certainly in the coming years. Now, this common platform concept that we are now, let's say, deploying in the company, in ST, this is obviously coming from the sheer, let's say, understanding that we can't afford to develop all these SoCs, let's say, independently from each other. It's just not possible anymore because of hardware design, but also because of software development. And therefore, we have to unify the platform. Yeah, unify the platform, which, as I said, is a way to freeze the choices of IP. Most of the IPs get frozen at that time. Then you instantiate that platform to SoCs. But these SoCs will basically use the, let's say, the underlying IP selected for your platform. And these platforms typically get upgraded on, let's say, every other year or every 2 years. Okay, so in terms of being on that platform, this is where you actually get design in, as opposed to being designed in on a specific SoC instantiation. So this is a trend that will probably continue going forward. So it's winner takes all, because if you're not in the UPP platform in this case, then it's going to be a while before you get an opportunity to come back on some of the next generation platform.